What actually happens inside your body the moment you stop eating? When does your body start burning fat? Will fasting make you lose muscle? When does autophagy start? Should you exercise while fasting? How long should you fast for the best results? In the next 7 minutes, we're going to break down exactly what happens to your body and brain as the hours tick by. Everything from the very first hour up to a full 48 hours of fasting. And along the way, we'll be dissecting the most asked questions about fasting across the internet using actual science. The clock starts now. Hours 0 to 4. Am I already burning fat? No, you're burning lunch. Right now, your body is in the postprandial state, meaning the food you just ate is still running the show. Glucose is everywhere. Insulin is high. Your cells are storing nutrients like it's inventory day. Your liver is packing away roughly 700 to 900 calories of glycogen. That's your short-term battery. Your brain? Calm, stable. Fat burning doesn't start because you skipped one snack. Relax. Hour 4 to 8. Why am I already hungry? Because hunger isn't a fuel gauge, it's a schedule. It's controlled by a hormone called ghrelin. Ghrelin rises according to your eating schedule, not your calorie needs. If you eat at 2 p.m. every day, your body rings the bell at 2 p.m. Even if you ate enough yesterday to survive an apocalypse, you're still running on glucose. You are not low on fuel. Ghrelin rises in waves, and if you ignore it, it drops again. Hunger works like a notification. It pops up. If you ignore it, it fades. Hour 8 to 12. When does fat burning actually begin? Now we're talking. Insulin levels fall. Your liver starts breaking down glycogen, that's 700 to 900 calorie backup supply. This process is called glycogenolysis. At the same time, tiny amounts of ketones, beta-hydroxybutyrate, begin appearing. That's not ketosis. That's ketosis warming up in the parking lot. Leptin drops. Your body has officially noticed energy in is lower than energy out. No panic, just math. Hour 12 to 16. Is this the metabolic switch everyone talks about? Yes, this is where the real shift begins. Glycogen is running low, insulin is low, fat breakdown increases. Fat cells release free fatty acids. The liver converts some into ketones. Ketones are alternative fuel for your brain. Your brain is now testing a new fuel source. This is the glucose to ketone switch, and some research suggests mild ketosis can improve mental clarity for some people because blood sugar fluctuations are reduced. Less roller coaster, more stability. Hour 16 to 20. Am I losing muscle? Surprisingly, no, because human growth hormone spikes during fasting. Some studies show increases over 1,000% in some cases. Why? Because your body wants to preserve lean mass while increasing fat breakdown. Insulin sensitivity improves here too, which means when you do eat again, your body handles nutrients better. This is recalibration, not destruction. Hour 20 to 24. Why did I lose so much weight already? Water, not wizardry. When insulin drops, your kidneys release sodium. When sodium drops, water follows. That dramatic first-day weight loss? You didn't evaporate fat overnight. You flushed fluid. Meanwhile, adrenaline rises. Fat breakdown accelerates. Inflammatory markers begin trending downward in many studies around this stage. It's not dramatic, but the shift begins. You might feel foggy. That's your brain switching fuel systems. Hour 24 to 28. When does autophagy begin? Now we're entering cellular housekeeping mode. The mTOR pathway goes down. The AMPK pathway goes up. That shift activates autophagy. Autophagy means self-eating. It's your cells cleaning out damaged components. Damaged proteins, recycled. Worn out parts, removed. Ketones also increase BDNF, brain-derived neurotrophic factor, supports neuron survival, supports plasticity. Your gut also finally gets a break. No constant stimulation of insulin, no constant digestive workload. For some people, that alone changes how they feel. Hour 28 to 32. Does fasting improve brain function? Yes, because things stabilize. Blood glucose settles lower but steady. Your body produces glucose through gluconeogenesis. Fat is primary fuel now. Ketones provide consistent brain energy. No spikes, no crashes. Even your heart runs efficiently on ketones. They generate more energy per unit of oxygen than glucose. From an evolutionary standpoint, when food is scarce, thinking gets sharper. Because if you don't think clearly, you don't eat. Survival upgrades cognition. Hour 32 to 36. Does ketosis keep rising? Yes. BHB continues climbing. Your body becomes metabolically flexible. Ghrelin waves again. Ketones themselves begin suppressing appetite, which is why, paradoxically, hunger often fades instead of intensifying. Many people report hunger decreasing after 24 to 36 hours. That's not willpower, that's hormonal adaptation. Your brain is adjusting to the new pattern. It's uncomfortable, but it's not catastrophic. Hour 36 to 40. Is my body repairing itself now? Autophagy becomes more robust, especially in organs like the liver and gut. Mitochondrial biogenesis may increase during this stage, meaning your cells can begin producing more mitochondria, more energy factories. In the brain, resistance to oxidative stress improves. Ketones enhance antioxidant defenses, shifting the balance away from cellular damage. The body also begins preparing for stem cell regeneration, though that peaks closer to 72 hours. But let's stay grounded. This is adaptation, not a superhero origin story. Hour 40 to 44. Am I preserving muscle now? Yes. As ketone use rises, gluconeogenesis slows, less amino acid breakdown. This is the protein sparing effect. Lean mass is protected. Meanwhile, GABA activity increases in the brain, which reduce stress and fear. Neural circuits stabilize. Some people report calmness, not enlightenment, just neurochemistry. Hour 44 to 48. So what actually happens at 48 hours? By now, glycogen is depleted, ketones are significantly elevated, insulin is low, fat oxidation is high, growth hormone remains elevated, stem cell activation increases further around this stage. These are undifferentiated repair cells, biological spare parts. Inflammation continues trending lower in many cases. Metabolism does not shut down, it adapts. But here's the part nobody romanticizes. Cortisol can rise, sleep quality can drop. Irritability increases. Fasting is stress, and stress is powerful in the right dose. Too little, no adaptation. Too much, no recovery. And before fasting turns into a personality trait, let's clear up a few more questions. Can I exercise while fasting? Yes, low to moderate intensity is usually fine. It can even increase fat oxidation. Walking, zone 2 cardio, light resistance work, but high intensity training suffers because glycogen is low. Does fasting reduce belly fat? Fasting reduces overall body fat. It does not target belly fat specifically, but visceral fat drops because overall fat drops. Does fasting reduce inflammation or disease risk? Short-term fasting can lower insulin and reduce inflammation. Autophagy and oxidative stress regulation improve, but long-term disease risk depends on overall lifestyle, not just skipping meals. How long should a fast last for best results? For metabolic flexibility, 14 to 16 hours is often enough. Longer fasts increase stress signals, such as ketosis and autophagy, but more isn't always better. Consistency beats extremes. Fasting is not magic. It's a fuel transition. Glucose to glycogen to fat to ketones. Hormones shift, cells adapt, the brain recalibrates, hour by hour. When you understand that, you stop fearing it and you stop worshiping it. Clock stops.